Very good. That is really dog and bugs. Genius.
Hey United, welcome back. Today we are starting our new topic, which is called statistics. We're starting off with the first lesson on a refresher of some stats you would have covered in maybe year 8 or year 7 to help you build a bit of confidence and make sure you're all caught up so we can start learning some new concepts in later videos. Okay, we're going to start off with an example on what I think of as the big four of stats from year 8. So these four words should hopefully be familiar to you. If you're a bit forgetful on which is which, that's okay. That's what today's video is all about. So we have the number of comments on the 8 latest mathematics videos recorded below. We've got 0, 7, 143, 0, 10, and 4. We're going to calculate the mean, we're going to find the median, we're going to state the mode, and then we're going to find the range. Okay, so first up we have the mean. So this can be thought of as essentially the mathematical or numerical average of the data set. So the way we find the mean is we add up all of our scores and then we divide that by how many scores we have. So for this example, we're going to do 0 plus 7 plus 1 plus 4 plus 3 plus 0 plus 10 plus 4. Because we have 8 scores, we're going to take that answer and we're going to divide it by 8. Please keep in mind that if you're putting this expression into your calculator, you need to use the brackets, otherwise the 8 is only going to divide the last score and not the whole thing. So if you do it correctly, you should get a value of 3.625. So what this means is, if we added up 3.625 8 times, we would get the same number as if we added up these 8 numbers. So they add up to the same thing. Okay, for question B, we're finding the median. So I always think that median kind of sounds like medium, and it's the middle of easy, medium, and hard. So the median is the score that splits the data set into 2 equal halves. So to find the median, the first thing you've always got to do is you've got to arrange your data set in order from smallest to largest, or ascending order. Now, when you have an odd number of scores, you're going to have one number that's in the middle. Because we have an even number of scores, there isn't one number in the middle. 3 and 4 are not either in the middle. The median is halfway between these two middle scores. So halfway between 3 and 4 is 3.5, and that is the median of our data set. There's the same number of scores to the left and to the right of 3.5. So sometimes the median will be a number in your data set, sometimes it'll be between two middle scores. So always got to be careful. Okay, now the mode is just the score that is the most commonly occurring. So mode is a French term that refers to most popular. So the most popular scores are the 0 and the 4 because they are double ups. The rest are only occurring once. So when you've got more than one mode, that's okay. You just write both of them. So for this one, our modes are 0 and 4. And the last one, probably the easiest, is the range. The range is just the distance from the start and finish of your data set. So it's how far from 0 to 10, which we can just do 10 take away 0, and so we get a range of 10. So the range is saying how many numbers does this data set span? Well, we're spanning from 0 to 10. So there you go. All right, let's do another example. Sometimes you won't be given the data set just as scores. Sometimes it'll be given to you in some sort of display. So here we have a dot plot, and it's our scores on a warm-up quiz from 27 students in our class. So most of the scores around 7, 8, and 9, which is good. One unlucky person having a bad day, getting a 1. Okay, this is a little bit more tricky. Down to find the mean, we've got to add up all these scores. So we've got a bit of calculation to do here. We've got to do 1 plus 4 plus 5 plus 5 plus 6 plus 6 plus 6, so on and so forth. If I did it correctly, hopefully all these numbers add up to 198, which I double checked. We can check that there's 27 scores, but the question says that there's 27, so we're pretty confident that's the right number. So the scores all add up to 198. We divide it by 27, and we get a mean of 7.3 repeater, or 7 and a third. Which looks like it's around here, which kind of looks like it'd be around the mathematical middle, so it makes sense to us. Okay, so for the median, once again, that's the middle score. So we've got to think, if we've got 27 numbers, where is the middle score? Sometimes that's a bit of a tricky question, so I'll show you a little trick that I use to help me figure out where the middle is going to be. What you do is you take your number of scores, you add 1 to it, and then you cut it in half. So 27 plus 1 is 28, divided by 2 is 14. So I know I need to be looking at the 14th score. That's going to be our median, okay? Because it's an odd number of scores, there's going to be 1 in the middle. It's going to be the 14th number. So if we count up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 right here, that is our median. So the median is an 8. And for C, we've got the mode, which is the score that has the highest frequency. We can see that the 8 is the most popular, so our mode is also 8. So mean, median, and mode are all considered different types of averages. So a lot of people, when they say average, they are usually talking about the mean, but median and mode are also types of averages. So the mean is the numerical average, the median is the positional average, and the mode is the average based on popularity. Okay, and to finish off, the range is from the highest to the lowest. So our highest score is a 10, our lowest score is a 1. So we've got a range of 9, easy peasy. Okay, sweet. Up next, we've got to look at some tables because sometimes data sets are too large to write out as a set of scores. And sometimes we don't have the time to make a display like a dot plot. So sometimes we can store our data as a frequency table. So this frequency table has the survey on how many Zoom sessions that students had attended in a week, and we're trying to find the mean. So we've got the scores here, and we've got the frequencies, which is how often they occurred over on the right here. What this means is that students responded they had 2 Zooms, 5 people responded that. Okay, 3 students said they had 3 Zooms in the week, 7 students said they had 4, so on and so forth. So if we were going to write these out, which we're not going to, we'd be doing 2 5 times, 3 3 times, 4 7 times, so on and so forth. Okay, we're going to look at shortcuts that allow us to not write out the scores, but still be able to accurately calculate the mean. Okay, we've got some extra work in our table to figure that out. This symbol right here, you may not have seen this before. It's a Greek letter. It's called sigma, and it represents sum. So this means sum of frequencies and sum of fx. Now fx over on the right, this literally just means f times x, frequency times score. So to fill in this column right here, we'd be doing 5 times 2, and we get 10. So on and so forth, we get 9, 4 7s are 28, and then we fill out the entire column. Okay, now we're going to fill in our total. So we're going to fill in the total of the frequency column, adds up to 25. So these numbers add up to 25. If we add up the fx column, we get 101. Now let's talk about why we found those numbers. We are trying to find the mean number of Zooms attended. So we're trying to find the numerical average. So we're trying to add up all the scores, and we're trying to divide by how many scores there are. So think about what's a shortcut. If we've got a 2 happening 5 times, what's the shortcut to doing 2 plus 2 plus 2 plus 2 plus 2? Well, the shortcut is 2 times 5, and our answer is right there. So these numbers in red over on the right hand side, these are essentially us doing multiplication as a shortcut rather than doing repeated addition. Okay, we don't want to add up a 4 7 times when we can just do 4 lots of 7 is 28, and there is the total of the 4s. Okay, what this means is that the total of the fx column, the 101, that is always going to be the sum of every single one of your scores in the data set. So we've got the total number of scores, we have the total scores added up. Now to find the total number of scores, we just add up our frequency column. This is how many scores we have. So if we add it up, we have 25 scores in total. So to find our mean, and a symbol that we can use for mean is this another Greek symbol. It's called mu, mu, represents the mean of the sample, which is what we have here. So we're going to do the sum of the scores divided by the number of scores. So we're going to do 101 divided by 25. So our mean is 4.04. Okay, cool. So if you see a table and they've given you an fx column, it's because they want you to use these 2 numbers as a shortcut to finding the mean, which when you get used to it is really, really handy. Okay, next special type of table, which you may have seen before, but potentially not, is talking about cumulative frequency, CF for short. So we had 98 students completed a 10-question science quiz. The results recorded in the table below. So the marks range from 3 to 10, and the frequencies are right here. We want to find the median result. So now we know there are 98 students. So if we want, we can do our shortcut to find where the median is going to be. But before we do that, we're going to fill out our cumulative frequency column, and we're going to talk about what that is and why it's useful for finding the median. So the cumulative frequency is essentially just your frequency column, but you're adding on as you go. So we're starting off with 2 at the start, so we have a cumulative total of 2. Now the next we have 5 more scores, so our cumulative total is now 7. So we're essentially adding on this number each time, and this number right here represents how many scores have you counted so far. So we started with 2, we counted another 5, now we'll count another 10, now we'll add on another 36, add on 25, so on and so forth, until right down the end we get 98, which is good because the question said there were 98 students in total. So you should expect the end of your cumulative frequency column to be your total number of scores because you've added on all of the scores as you go. Okay, and likewise, if we added up all our frequencies, we get 98. So if these two numbers match, you know you've done it correctly. Okay, now we have 98 scores. So where is the median going to be? Well, let's use our trick that we looked at before. We're going to do 98 plus 1, and then we're going to divide that by 2. So half of 99 is 49.5. This tells me that our median is going to be between the 49th and the 50th score. Okay, because we have an even number, it's going to be between the two middle scores, which are 49 and 50. So now this can be easier to find because we have our cumulative frequency column. So we can pretty easily see where do the scores tick over into the 49th and the 50th. So we have 2 in the 3s, then the 4s bring us up to 7 scores, the 5s bring us up to 17, and now the 6s bring us up to 53. So by adding on all these 6s, we've gone past 49 and we've gone past 50. So both the 49th and the 50th score are going to be 6s, which means our median is also going to be a 6. And there we go, there's our median. Okay, so if a question or an example is asking you to use a cumulative frequency column, they're wanting you to use that to help you find the median more accurately, because it would be a bit harder working off just these numbers. Okay, there we go. We're going to finish off with a couple of quick challenge questions. So here's the first one. Bit tougher than what we've done already today. We've got a team of 5 basketballers have a mean height of 190 centimeters. So 5 players, numerical average is 190. We have a 6th player join the team, and now the mean increases to 192. So our new player must have been taller than 190. The question is, how tall is that new player so that our new mean is now 192? You're welcome to pause the video and have a go if you want. I know a lot of students, when they're new to questions like this, they'll probably solve it using trial and error. You can do that if you want, but I'm going to show you a way that we can solve this question without using any trial and error, just using some maths. Okay, so starting off, we know of course that the mean, which again that little symbol there, Greek letter mu, mu for mean, is the sum of the scores divided by how many scores there are. So all we really need to do here is use this mean formula, but we're going to be working backwards because this time we already know what the mean is. We're trying to figure out what one of the scores is. Okay, so here's the golden ticket. Here is our mean formula. We know that we have 6 players. Okay, it's 6 numbers being divided by 6, and the answer is going to be 192. That's our new mean. All right. Now the issue is, but we don't know what the 5 players' heights were. So how can I write 190 here 5 times? Well, that is the beauty of the mean. So because we have 5 basketballers and they have an average height of 190, if you added up their 5 heights, it'd be just the same answer as if you were doing 190 multiplied by 5 times. Okay, so I don't know what the 5 heights were of the previous players, but I do know that if I added them up, I would get the same answer as this. That allows us to make this equation. We have the 6th player as x, representing something that we don't know yet, and now we can solve this equation for x. We can multiply the 6 across. The 190 multiplied by 5 gets us 950. So the top of the fraction turns into 950 plus x. The left-hand side turns into 192 times 6, which works out to be... okay, so now we're going to work backwards. We're going to solve for x by subtracting 950. So we'll do 192 times 6. We'll take away the 950, and this will get us the value of x. So it works out that x equals 202, which you may have figured out by doing a bit of trial and error, but here's how we can use a direct algebraic method that gets us a correct answer without any guessing and checking. Okay, cool. One last question for you guys. Another challenge question. We've got a data set of 8 scores, and they've been written in ascending order, but 3 of the values have been left unknown. So we've got A, B, and C. We don't know what they are. Some information is that the median of the data set is 11, the range of the data set is 16, and the mean of the data set is 12. The challenge is to find the values of A, B, and C that make these values work in this ascending set of data. I'm not going to run through this one in the video. I reckon you guys can handle this by yourself. If you have an answer for A, B, and C that you feel confident with, post it down below in the comments and I'll let you know if you're correct or incorrect. All right, cool. Thanks for watching. I'll see you guys in the next video, and let me know if you need more examples or help with the work posted today. Take care. Bye.